So today we're going to talk about your last three shapes. And I'm just going to warn you guys, the test for Chapter 6 to me is kind of hard in the sense that there's so many things from first semester we have to remember. We've been reviewing them, but it's still stuff you have to remember. So things like, we're going to talk about Pythagorean theorem again today. You have to remember how to prove triangles congruent from last semester. You have to use things like vertical angle theorem and parallel lines cut by a transversal. Things like that come back in this chapter. You're going to have to be able to solve systems of equations. You're going to have to be able to solve quadratics. Those are going to come back in this section. So some of those things aren't hard, but there's just so many things from before. And then you've got all these properties that you're going to have memorized. And some of them you've got down already just because you've used them several times now. But some of you may still be pulling that property sheet out for every problem that you do, and you won't get that property sheet for the test. So you need to be practicing memorizing your properties. A couple of ways you can do that. Have somebody quiz you. List all 5 properties of a parallelogram, or name the 6 ways to prove it's a parallelogram. You could just write them down over and over until you've got it. But you've got 7 shapes at the end of the day today that you have to know their properties for. Some of them only have a couple properties, like the rectangle. It only has 2 extra properties. Okay. It's coming over the phone now, a little at a time. When is our test going to be in here? Next Wednesday. Remember, it normally would have been Tuesday, but there's no school Monday. So you'll review Friday, which is an A day. Tuesday will be a B day, and that means Wednesday's an A day. So you have until next Wednesday, a week from today, to have all your properties memorized. If you just take one shape every day, that shouldn't be too difficult to kind of start practicing that memorizing, okay? Make a Quizlet if you want to of all the properties and then have it quiz you. Something, because knowing the properties is the only way you're going to be successful on the test, okay? Other than that, it's not super difficult, but there are some problems I'm worried about just because there's so many things you have to remember. Okay, so we're going to start with kites today, and then trapezoids, and then isosceles trapezoids, and then we'll be done. A lot of vocabulary today to go over. So property sheet first. Make sure you've got your property sheet handy. Start with your kite quickly because we're gonna go pretty fast, so I'm not wasting your time. Definition for a kite does not change. It is not a parallelogram. A kite is only a quadrilateral. Its definition says it's a quadrilateral with what? Okay, it's going to have 2 pairs of congruent consecutive sides. So 2 pairs of congruent consecutive sides. So a kite looks like a traditional kite that you would fly in the air. It's going to have 2 sides that are congruent and then a different 2 sides that are congruent. So it's going to have 2 pairs of consecutive congruent sides. Okay? There are also some other properties with your kite. So the next property that you need to know about your kite is that it is also going to have perpendicular diagonals. Bless you. Perpendicular diagonals. What other shape has perpendicular diagonals? Not a rectangle, a rhombus. That is why I stressed so much last class period. To prove you have a rhombus, what do you first have to prove? It's parallelogram. So just having perpendicular diagonals is not enough. You have to know it's a parallelogram with perpendicular diagonals. If it's not a parallelogram and it has perpendicular diagonals, that's going to prove it is a kite. Okay? So if you have perpendicular diagonals but it's not a parallelogram, then it has to be a kite. Keep in mind, if you have perpendicular diagonals, when you draw those in, what do they form where they intersect? Right angles. So you end up with what kinds of triangles here? right triangles. So you end up with 4 right triangles, which could result in us needing to use Pythagorean theorem or special right triangles. Second, let's think back to last semester. If I use the reflexive property right here, would you agree that this is congruent to itself? Okay, so that means if I have a right triangle and the hypotenuse is congruent and a leg is congruent, what does that mean about these two triangles? They're congruent. And the same thing down here, if I use the reflexive property with this piece, we would have hypotenuse, leg. So these two triangles are congruent. Do you agree with that? So your kite is not going to have 4 congruent triangles like your rhombus did, but it is going to have 2 pairs of congruent triangles. It's not really a property that we list, but I want to make sure that you see that in your kite, that you're going to have 2 pairs of congruent triangles, because that's going to be helpful if you're trying to find missing angles or sides. If you know the triangles are congruent, all their corresponding parts are congruent. Okay? Last property for your kite is that the kite will have exactly 1 pair of opposite angles congruent. It's going to have 1 pair only. 1 pair of opposite angles congruent. But not just any pair. It is a specific pair that's going to be congruent. So when you look at your kite, the pair of angles that are going to be congruent are the pair of angles that are formed by the 2 sides. Oops. I hate it when I do that. Why do I do that? It's so frustrating. Okay, it's going to be the 2 pairs that are formed by the 2 sides that are not congruent. The 2 sides that are not congruent. So when I look at my picture up here, this is A, B, C, D. Which 2 angles will be congruent? Okay, B and D. This angle will be congruent to this angle. It's the ones formed by the 2 sides that are not congruent. The 2 sides that are congruent, the angles in between those are not going to be congruent angles. So A and C are not going to be congruent. So I usually put here, it is the angles formed by the non-congruent sides. If you can think of it a better way, then write it down however it makes sense to you. But the 2 sides that are not congruent, the angle it forms, those opposite angles will be congruent. Okay? Keep that in mind. That means if you look at this big triangle ABC and this big triangle ADC, you have side, angle, side. So those 2 great big triangles will be congruent to each other also. Is everybody okay with that? All right, that's your kite. We're going to go ahead and look at some examples, and we're going to start with the longest, hardest one first, which is this one. So I want you to go ahead and take a couple minutes, read through this problem, and see if you can come up with some ideas of what to do. Okay, I'm going to go ahead and stop you. I'm not asking you to work the whole problem by yourself, but let's see if we've got some ideas here and that you even understand the problem. What shape do we have? A kite. And we're talking about basically building the frame for the kite. So she's going to use some wooden dowels to make her kite. We've got 18 centimeters here and here, 27 here and here, and then she has one dowel that's 30 centimeters. What is this 30 referring to in our picture? JM. So we know this distance is 30. And then it says that she needs one more dowel to go along the length of K to L. And she has 36 centimeters left. That's how long her dowel is. And we want to know how much will we have left after we make KL. So what are we going to have to do once we figure out the length of KL? Subtract it from 36. So final answer is going to be 36 minus KL. The question is, how can we find the length from K to L? Suggestions that you've thought of already. Okay, so where are you getting the idea that we're going to use Pythagorean theorem from? You bet. So Elijah's talking about the fact that the diagonals are perpendicular. And if they're perpendicular, that means we have 4 right angles. And then you said 15. Where did you get 15 from? Exactly. If we know these 2 triangles are congruent and these 2 triangles are congruent, then that means that this piece has to be equal to this piece. So 30 divided by 2 would be 15. Is everybody okay with that part to start with? And then Elijah, when you were saying 15 and 27, you were looking at this triangle right here, right? So that's going to help us find this length. Then what will we have to do? You're perfectly correct. We're going to have, good. So then we're going to go on to the other top part, and notice we have another right triangle, and we're going to have to find this length by using the 15 and the 18. So does everybody see that we're going to have to do Pythagorean theorem twice? And then we're going to take those 2 values and do what with them? Add them together. That's going to give us the whole length of KL, and then we're just going to subtract that from 36. Okay? So let's do that real quick together, and if you're watching the video, it's filled in on the notes, but I'm going to work it on the whiteboard so you won't actually see my work right now. But look at the filled in notes. So first thing we're going to do is what Elijah said. I'm going to come down here, and I'm just going to go ahead and label this so we can talk about it, and I'm going to call this point S. Okay? So we're looking at this triangle JSL. That's the first one he mentioned. JSL. This was a right angle. This was 27. This was 15. Using a squared plus b squared equals c squared. What has to go in for c? 27. And then 15 squared plus, and I'm just going to call this x. So what's 15 squared? 225 plus x squared equals, what's 27 squared? What is it? 729. From there, what do? Subtract the 225. So we have x squared equals 504. To solve for x, we're going to take the square root. So we have x is equal to the square root of 504. So I'm going to stop you for a second. When we read the question, what does it specifically say for the last sentence? About how much wood. So what does that mean if it says about that we can do? We can round. This is telling us we can estimate. We can round. But is this our answer for our question? No, so don't round this answer because this is not your final answer. So I'm not going to worry about trying to simplify it and put it in simplest radical form because it's not my final answer, and it said I could round when it said about how much. So we're going to just leave this as square root of 504. That's going to go here for this distance. Right here from S to L. And then now we're going to go on and try to find K to S. So doing the same thing, I'm going to draw the other right triangle. This is J, this is S, and this is K. We know this is 18, and we figured out this was 15. And so again, we're looking for KS. I'm going to call that Y. So I have A squared plus B squared equals C squared. What has to go in for C? 18. And then it doesn't matter. 15 and Y can go in either order. 15 squared plus Y squared equals 18 squared. We already know 15 squared is 225. What is 18 squared? 324. Same process, we're going to subtract 225. What do we get for Y squared? 99. And then we'll take the square root. We could simplify it, but once again, it's not our final answer. It said we could about how much, so we can round. So from here, we're just going to take these two values and do what with them? Add them together. Be careful. Go back to last semester and think about all that time we spent on radicals. If you want to find KL and you add the square root of 504 plus the square root of 99, can you add those numbers together? No. The only way you can add square roots is if the radical number is the same. So you can't really add them. You're going to type them in on your calculator. When you do, be very careful that you end the square root. Every now and then I'll see a student who does this. And then they have the square root over the whole thing because they forget to stop the square root. So be really careful that you end the square root on the 504. Okay? So tell me what you get when you plug that in. 32.39. Okay, and that keeps going. Is that our answer? No, the question was how much does she have left? So we need to take 36 and subtract this number in our calculator. And then we can round. It doesn't say what to round to, so I would accept any answer on your homework, whatever you want to round it to, but we'll just round to the nearest tenth. So what do we end up with here? We subtract these two numbers, what do we end up with? 3.6. Okay, if you take this and subtract 36, it's going to give you a negative, or you could do 36 minus this. But either way, if you round to the nearest tenth, you should end up with a positive 3.6. What are our units? Centimeters. So she will have about 3.6 centimeters left. Okay, one thing that I have not been very good about in here stressing and knowing where you're headed next year, I want to make sure I start stressing this. When you have a word problem, when you go into Algebra 2, they are going to require you to write a complete sentence every single time. And you have to identify your subject and make sure that you're explaining the problem. So what would we say if we wanted to answer this question? Very good. Lucy will have about 3.6 centimeters of wood left. Make sure that you're answering the questions in complete sentences, spelling correctly, using proper grammar. As you start to head into Algebra 2, it's going to be more important that you're practicing those skills. I'm probably a step up from Algebra 1 in that I do count off for spelling. I encourage you to use correct grammar, but I don't always count off for complete sentences and all of that. So when you get to Algebra 2, they're going to step it up just a little bit more. Complete sentences, identify your subject, all of those things. Okay, just want to encourage you to start practicing that now so it doesn't haunt you next year. Questions on this problem? Okay, that was the hard one. So if that's not too bad, you'll be good. I want you and your partner to go ahead and look at how many examples are left on the kite. Are there 3? Before it talks about trapezoids? 3? So okay, you guys take a couple minutes and do the next 3 problems on the kite. See if you can figure those out. We're going to go ahead and start. So I want you guys to help me out explaining and making sure we're all clear about some things here. We have a kite, and I think all 3 questions were the same picture, right? Okay, so I'm just going to label one picture here. DAB was 54 degrees. CDF, this angle right here, was 52 degrees. And they wanted me to find angle BCD. So B to C to D. So let's just make sure we're all clear about a couple of things. In our kite, number one, they did not tell us which sides were congruent. I don't like that. They should have told you which ones were congruent. You had to look at this and assume you knew which ones were congruent. It was pretty obvious, I hope, that this side's congruent to this side and this side's congruent to this side. Would you guys agree? Okay. But technically, they should tell you which ones are congruent in your kite. From there, make sure you remember, you only have one pair of angles opposite that are congruent. Which angles are going to be congruent? B and D. So these two are going to be congruent. But you also have two pairs of triangles that will be congruent. So that means triangle number 1 here and triangle number 2 are going to be congruent. Triangle 3 and triangle 4 are going to be congruent. For that reason, if these two triangles are congruent, what does that mean about these two angles? They're bisected or they're congruent. And the same thing down here, these two triangles are congruent, so this angle will always be bisected. So one thing you could think about is, in a kite, one pair of opposite angles are congruent, and the other pair of opposite angles are bisected. Does that make sense? You don't really have to memorize that. If you just think about the fact that these triangles are congruent, that will occur. Okay, so we want BCD. Tell me what you did. Somebody. Jedi, go ahead. Okay. Gotcha. So ready with Jedi, that if these two triangles are congruent, this angle over here is also 52 degrees? Okay. So we knew the diagonals were perpendicular, which meant there were 4 right triangles. Okay, so he's saying that all 3 angles in the triangle have to add to be 180. So if this is 90 and this is 52, we can do 90 plus 52 and subtract it from 180. Or you can also do the shortcut of 90 minus 52. Either way, you're going to get 38 for this little angle. Is that okay? Everybody got that? And then if this is 38, then this angle had to be 38. And so this whole big angle was how much? 76 degrees. Questions on the first one? All right, I love that. That's a great way to do it. Okay, next question. What did the next one ask you to find? Measure of angle ABC. Is that correct? Okay, ABC. So now we're over here with this angle. Remember, that is not bisected. These two triangles are not congruent. So you cannot just take 52 times 2 and say it's 104, which is the most common mistake I usually see. So be really careful there. So how do we find this angle in order to find this whole angle? Go ahead, JP. ABC. So ABD would be needed, yes.
You add 54 to 90, since you already know 90 degrees, then you subtract that.
Be careful, 54 is this whole angle. Right. So we do know this angle is bisected because these two triangles are equal. So that makes this angle half of 54, which is 27, and this angle is half of 54, which is 27. So we can do 90 plus 27 from 180, or we can just do 90 minus 27, which is 63. You guys with me? So that's this angle right here. And then what did you do to figure out this whole big angle ABC? Add them together. So 63 plus 52 gave you 115. Don't forget your degree symbol. Don't forget the little m. Questions on that one? Okay, if you did it that way, then you should have been able to answer the last question really easily. The last question was, what is the measure of angle ADF, which was this angle right here? And we know that angle should be the same as ABF, which is 63. So the last one should have just been 63 degrees. So that's this one. So FDA should have been 63 degrees. Questions on the kite? Okay, let's move on to the trapezoid. Last shape we have to talk about is the trapezoid. The trapezoid is going to have two kinds of trapezoids. A regular trapezoid and then an isosceles trapezoid. Starting with the definition for a trapezoid. The definition says it is a quadrilateral. It is not a parallelogram. It is a quadrilateral with one pair of one pair of opposite sides. One pair of opposite sides parallel. One pair of opposite sides parallel. Okay, so if I look at my picture, once you write that down, that is the only property we're going to list for the trapezoid. Its definition has one pair of opposite sides parallel. Before we look at the rest of the vocabulary, though, think about this with me. If I have a trapezoid, and right now all I know is that one pair of opposite sides are parallel. Think back to chapter 3. What's going to be true if this is a transversal about these two angles? I think you're thinking what Devin just said, which was supplementary. These two angles are same side interior, so they're going to be supplementary. What's going to be true about these two angles? They're going to be supplementary also because they're also same side interior. These two will not be supplementary because these two sides are not parallel. These two will not be supplementary either. So it doesn't have the property like the parallelogram that has consecutive angles are all supplementary, but it does end up with two pairs of consecutive angles that are supplementary. Okay, so I'm not going to write that down as a separate property, but I want you to remember anytime you have parallel lines, you need to think about those angles like same side interior, alternate interior, those things apply. Okay? All right, vocab for your trapezoid. What are we going to call these parallel sides? The bases. Each of the parallel sides is called a base. So when it talks about the bases, it's talking about the ones that are parallel. The other pair of sides that are not parallel are going to be called what? The legs. So every trapezoid has a pair of bases and it's got a pair of legs. And then it's going to end up with two pairs of what we call base angles. The base angles are the two consecutive angles that share a common base. So when you look at our picture here, this base BC creates angles B and C. Therefore, they are base angles. This base down here forms angles D and A, so they are base angles. Is everybody okay with what a base angle is? Okay, so you have two pairs of base angles. A and B are not base angles together because they have different bases. Okay, then the last shape you're going to write down on your property sheet is isosceles trapezoid. And if it's an isosceles trapezoid, it is definitely what shape? A trapezoid. So the first thing that's true about the isosceles trapezoid is it is a trapezoid. So it has all properties, which really is just one property. It has all properties of a trapezoid. But it does have some of the things we talked about, like two pairs of consecutive angles supplementary. So it has all the properties that would be for a normal trapezoid. And then it also has, by definition, legs that are congruent. So if it's isosceles, its definition says that it will have congruent legs. And then it's going to have some more properties. So if it's an isosceles trapezoid, it will have congruent legs. Just make sure you understand what that looks like. It's going to have bases that are parallel, but then the legs will be congruent. The next thing that's true for an isosceles trapezoid is, it's going to have two pairs of base angles that are congruent. Two pairs of congruent base angles. Two pairs of congruent base angles. If it's isosceles, those base angles will be congruent. So if you look at the picture, notice B and C are base angles, so they're congruent. A and D are base angles, so they're congruent. Any questions so far? This is just the converse of this. It says you can prove it's an isosceles trapezoid if it has congruent base angles. It's actually going to say that you only need one pair of congruent base angles to prove it's an isosceles trapezoid. Okay, but it's just the converse of that. The last property you're going to add to your property sheet is this one right here. And it says that if it's an isosceles trapezoid, it will have congruent diagonals. Congruent diagonals. What other shape has congruent diagonals? A rectangle. So again, that's why I stressed, if you just have congruent diagonals, that's not enough to say that it's a rectangle. It's got to first be a what? Parallelogram. If it has congruent diagonals and it's a trapezoid, then it's an isosceles trapezoid. Are we clear? Okay, so now we're going to do two things. We're going to finish our Venn diagram, and then we're going to work on some examples that are left. So somewhere you wrote down a Venn diagram in here, right? Did we not make a Venn diagram in here ever? Well, why didn't we do that? I don't know. We're going to make a Venn diagram. So let's do that real quick. You can put it on your property sheet if you have room, or on your notes, wherever, but this will help you with those always, sometimes, never questions that will be on your test. Okay? So you need to create a pretty large rectangle, especially if you write big like I do. Okay, so we're going to make a large rectangle somewhere. If you don't write that big, it doesn't have to be as giant as mine. We started off this chapter talking about polygons in general. Then we focused on just the four-sided polygons. What do we call four-sided polygons? Quadrilaterals. So I'm only going to draw my Venn diagram for what we spent the rest of the chapter on, which was the quadrilaterals. So inside this rectangle, we're going to list all the quadrilaterals that we've talked about. And there should be 7 of them. Okay, the first group of quadrilaterals we talked about were the what? Parallelograms. So I'm going to draw a great big circle or rectangle, whatever you want. And that's going to contain all my parallelograms. So if it's a parallelogram, it is also a quadrilateral. But it can be a quadrilateral and not be a parallelogram. So that's how we can use that Venn diagram. Inside my parallelograms, which shapes were parallelograms? Rhombus, rectangle, and square. One of them was made by combining the other two. Which one is made by combining the other two? The square. So if you combine the rectangle and the rhombus, if it's both a rectangle and a rhombus, then it is a square. So one of your circles inside the parallelograms needs to be rectangle. The other circle needs to be rhombus. And it doesn't matter which one's which. But where they overlap, that's the shape that has all properties of a rectangle and a rhombus, which is a square. Okay? So always, sometimes, never. A square is always, sometimes, never a parallelogram. Always. A rhombus is always, sometimes, never a square. Sometimes. Okay, so those are how you can kind of use that. Inside here, we had some other quadrilaterals today that are not parallelograms. One of those was the kite. First one we talked about. A kite is not a parallelogram. It is also not a trapezoid. It's all by its little self. It's special. And then we had the other group, which were the trapezoids. And inside the trapezoids, we had a special kind of trapezoid, which was the isosceles trapezoid. And so an isosceles trapezoid is always a trapezoid, but it is never a kite. It is never a parallelogram. It is always a quadrilateral. Does this make sense? Okay. So here's kind of your Venn diagram just to put it all together, all 7 shapes. You've got all your properties. And now we're just going to work a few more examples throughout the notes on trapezoids, and then I'll let you work on homework. You already have your assignment slip, so it's nothing extra today. Just what you already have is due Friday, along with your vocab test Friday. So why don't you, let's see, there are, still Sean's here, 1, 2, okay, 4 examples before we talk about what is a mid-segment. So go ahead and do the next 4 examples, you and your partner, and then we'll check them. Okay, that was a quick 30 seconds, but here we go. We're going to come back up here. If you're still working, feel free, but make sure you at least pay attention to check your answers and know if you got them right or wrong. So key thing here is, what shape do I have here? Isosceles trapezoid. So some things you know about isosceles trapezoids. They have congruent base angles. So if this is 100, this is 100. These 2 lines are parallel, which means these 2 angles are what? Supplementary, because they're same side interior. So if this is 100, what does A have to be? 80. And the question was, what is the measure of angle A? So you should have ended up with 80 degrees. Questions on the first one? Okay, moving on. Please stop me if you have a question though. This one, it says KB is 21.9, which was this little piece here. And then they told you that M to F was 32.7. What property did you have to use to start with? Diagonals are congruent because this is what kind of shape? Isosceles trapezoid. So I know it has congruent diagonals, which meant that JK was also 32.7. So to figure out this little piece BJ, what did you do? Subtracted them. 32.7 minus 21.9, and you should have gotten 10.8. That isn't really FB. That's BJ, right? Are you guys with me? But these 2 triangles are going to end up congruent to each other. So this triangle will always be congruent to this triangle, which means if BJ is 10.8, so is FB. Okay, so this is also FB. Questions on that one? Okay. And then the next one. What property did you have to start with on this one? Okay, it says find the value of A so that this is isosceles. If it's isosceles, then the base angles should be congruent. So A squared plus 27 should equal 2A squared minus 54. From there, you should subtract the A squared to get 27 equals A squared minus 54. Add 54, and you get A squared equals 81. Stressing to you again, where you will start in Algebra 2 will be with quadratics. A quadratic is anything to the second power. Some quadratics make us use the quadratic formula. Some we can factor. Some we can just use square roots. This is one where we can just use square roots. When you take the square root, though, you do not just get 9. Come on. Okay? It is not just 9. Every quadratic should get 2 solutions. Sometimes it's the same solution. Sometimes it's different solutions. You should always remember when you take the square root of both sides to put what? Plus or minus. If you were trying to find the angle measure, it would not matter because you would just plug that in and square it. But because the question said find the value of A, it does matter. A is positive or negative 9. Okay? Also be careful. You have to check in geometry to make sure that that negative 9 doesn't give you a negative angle measure. When I plug it in and I square it, what happens to it? It gets positive. So it's still going to give me a positive angle measure. So I'm okay. So it is both positive and negative 9. Yes, ma'am. Who? I'm sorry? Jonah? Why am I? Oh, Bailey. Jonah, you okay if she pulls you out? Adios. See ya. Okay. All right. Are we good here? Last one. Then we're going to talk about mid-segment, and then we're done. So on this one, what property did you have to use? Okay. If we want it to be isosceles and it's a trapezoid, it has to have congruent diagonals. And they told us this is AD, this is BC, so they're giving you the diagonal lengths. If you want it to be isosceles, those had to be equal. So you should have said 12x minus 11 equals 9x minus 2. From there, what did you get for x? 3. Okay, I'm going to warn you guys. I put this in the notes for Mrs. King. But you have to be able to solve quadratics on the test. And it's been that way for the last couple tests. Would you agree I keep putting quadratics on your tests? It's not going to go away. I'm trying to help you prepare for Algebra 2, so make sure you can solve quadratics. All right, last concept for today. Any questions before we go on? Mid-segment. If you're dealing with a trapezoid, it's going to be very similar to a triangle. So let's review real fast the triangle. Last semester, we said if we had a triangle, what was a mid-segment of a triangle? Okay, how do I even make a mid-segment? What does it connect? Midpoints. So I would take the midpoint here and a midpoint here. Those did not have to be equal lengths, but they had to be split into 2 congruent parts. And when you connected them, that formed a mid-segment. And then you said the mid-segment was what? Half of the other side. So if this was x, this was half x. What else was true about this line and this line? They were parallel. Okay, but in a triangle, how many mid-segments could you create? 3. Remember we talked about how you could even have a mid-segment triangle. You could have a mid-segment on this side as well, and then you have a midpoint on this side, and then you have a mid-segment and a mid-segment, right? And that would make this side parallel to this side, and so on. The trapezoid is similar but different. The definition for mid-segment on a trapezoid is it does connect to midpoints, but not of any 2 sides, only of the legs. So whichever sides are parallel, those are your bases. Your mid-segment connects the midpoint of the 2 legs. So how many mid-segments can you have in a trapezoid? Only 1. Okay? It is still going to be parallel to the bases, but now there's going to be 2 bases. So here's the first base, here's the second base. In a triangle, there was only 1 base, so it was just parallel to that 1 base. In a triangle, it was half of that base. In a trapezoid, this mid-segment is not just going to be half of this base. Would you agree that this is actually longer than this? Okay, so what do we need to do to find the mid-segment here? Exactly. We need to average it. The mid-segment's going to be the average of those 2 bases. So you're going to take base 1 plus base 2, add them together, and then take a half. So it's very similar to the mid-segment in a triangle. It is half, but it's going to be half the sum of those two bases. If you look in your notes, it's the next theorem in your notes. It's called the trapezoid midsegment theorem. And it simply says the midsegment's parallel to each base, and it is half the sum of those bases. So you add BC and AD together, and then you take a half. All right, last example, and then I'm going to talk to you about something else you'll see on your homework. So look at this example. What's EF? It's a midsegment. We know that because midpoint, midpoint, midsegment. So how do we find the distance from E to F? Good. 13.5 plus 8 and divide it by 2 or take a half. So what do you get for E to F? 10.75. Okay. Be careful. What if they gave you this picture? What would you do to solve for x? Oops. What would I do? Oh, why am I keep doing that? Okay, so Brendan said 1/2 of x plus 3 plus x equals 12. So just make sure you can go backwards. If they give you the midsegment, you can still plug that into the equation. Add these together and then take a half. Questions on that example? Questions on anything from today? All right, we are done. You may